This is a review of integrals. Let's try a sloped line. That function is y equals mx. And consider the integration limits x equals 0 and x equals a. This is the area that we want to compute our integral. And we can say by the time it gets to x equals a, that it's at y equals. So the area here is 1/2 b times a. And that should be a familiar formula for the area of a triangle, 1/2 base times height. In this case, the base is a and the height is b. That information also allows us to say the slope equals b divided by a. The integral looks like this. It's the integral of y with respect to x. The limits are x equals 0 and x equals a. And then we'll substitute in our specific function. And notice that m is a constant. We can actually bring that out of the integral or keep it inside. Either way, the answer is going to be the same. I'll rewrite it with m outside. To solve this, we start out with m, and then it's times x, but this is x to the first power inside the integral. So we add 1 to making it x squared, and then we divide by that new exponent, 2. And I have to put on the limits, x equals 0 and x equals a. Evaluating that at the first limit, x equals a, we have m a squared divided by 2, and then the second one is minus 0. If we substitute in what m is, in this case for a, then we can rewrite this as b over a times a squared over 2. We can cancel out one of the a's and end up with 1/2 b times a, which is the area we got here. An important point is we should be able to take the derivative of our indefinite integral and get right back to the original function. That's an important way to check your results. In this case, the indefinite integral is m times x squared over 2. I can write the derivative of that indefinite integral as this, d dx of mx squared over 2. And I bring that exponent out in front, 2mx, now it's to the first power, because I subtracted 1 off the exponent, and that's still divided by 2. And that simplifies to mx, which is the original function we had, y equals mx. It's always a key check to do. Taking a derivative is often easier than integrating, and you want to make sure that you can get back to the original function. I hope that helps your math.